On May 4th, a magnitude 5 Marsquake struck the surface of Mars, making it the biggest quake ever recorded on any planet other than Earth. But what is a Marsquake? How exactly was it recorded? Let's find out. The InSight lander, sent to Mars in 2018 by NASA, has recently made a groundbreaking discovery, detecting Marsquakes on the red planet. According to scientists, these seismic waves can give us insight into the depths of Mars's interior layers and provide new information about its makeup, structure, and activity. The magnitude 5 event detected by InSight is highly unusual because Marsquakes are not commonly observed like earthquakes on Earth. This rare find could offer a glimpse inside the mysterious Martian core previously out of our reach. Scientists believe that understanding how this core behaves may help us answer critical questions about Mars's past and present geological activities, as well as its potential for future exploration. Hopefully, further analysis of the data will help us gain new insights into the Martian core and its possible role in shaping our neighboring world. A recent study, Duran et al., described one of the largest and most remote seismic events yet observed on Mars in a recent publication. The pressure waves, P waves, were the first of their kind to go more than 800 kilometers beneath the surface of Mars and all the way to the core, where they were diffracted. The event, which turned out to be an impact, happened close to Mars's Tharsic volcanic plateau, on the other side of the planet from InSight, according to authors' analysis of the vibrations, which was in line with satellite pictures that showed the impact site. A Marsquake is a quake like an earthquake that would cause the surface or interior of Mars to shake due to a sudden release of energy within the planet, perhaps as a result of plate tectonics, which causes the majority of earthquakes on Earth, or perhaps from hot spots like Olympus Mons or the Tharsis Montes. It may be possible to learn more about Mars's internal structure and whether any of its numerous volcanoes are still volcanically active by detecting and analyzing its Marsquakes. Scientists theorize that the core of Mars formed from a process called accretion, which involves small particles sticking together to form larger and larger bodies in space. It's believed that these particles collided with each other to form a molten core, made up primarily of iron and nickel, surrounded by a mantle of silicate rocks and an outermost layer of soil and rock. The inner core is estimated to have a radius of between 800 and 1,300 miles, 1,200 to 2,000 kilometers. Scientists believe it could be composed mostly of iron and sulfur with traces of oxygen, magnesium, and silicon. Though the data collected by InSight will help researchers better understand the exact composition and structure, they already know that it's far denser than Earth's core. That suggests that the Martian core is still largely molten and active, generating a magnetic field that could help protect against deadly solar radiation. Evidence of an active core on Mars comes from the seismic waves detected by InSight. These waves can tell us a lot about the planet's internal structure, including how deep its core is and what it's made of. Since seismology relies on measuring the speed and direction of seismic waves traveling through different layers, scientists have used this data to infer that the Martian core is still active beneath the surface. This suggests that Mars has a liquid molten outer core, which could be responsible for generating its magnetic field. This would explain why Mars's magnetosphere currently shields it from much of the radiation coming from space, as well as why there are remnant signs of magnetism found in ancient Martian rocks. The presence of an active core suggests that Mars may generate its own heat, rather than just depending on what it receives from the Sun. This could have implications for Martian geology and understanding of the planet's evolution. Knowing whether or not Mars's core is still active is key to unlocking its geological history. The InSight lander is helping to prove that the core of Mars is still active. By detecting and analyzing seismic waves, it can provide insight into the geological layers beneath the surface of Mars, including its mantle and core. This data helps scientists to determine how much energy is being released from deep inside the planet as it moves and shifts around its core. As well as providing information on current Martian activity, they may also be able to use this data in future research on how long ago certain features were created. By further understanding Mars's current activity, we can begin to gain a better understanding of the planet's history and uncover more about our closest planetary neighbor. On April 6, 2021, The InSight mission recorded a meteor impact on Mars that was the strongest ever detected. The impact registered an estimated energy of 4.2 kilotons of TNT and had a magnitude of 3.8 on the Richter scale. It was so large that it rattled the seismometer on board InSight and could be heard from Earth by amateur astronomers. This is significant because it proves that the Martian core is still active after billions of years and can produce seismic events even from impacts from space. It also suggests that there may be other similar events taking place on Mars as well, which means more evidence for scientists to analyze our neighboring planet's formation and evolution over time. This data could have implications for our understanding of the solar system as a whole. Furthermore, this meteor impact proves that InSight is still working and gathering valuable data about Mars even after its primary mission has ended. This is an incredible achievement for the team behind the mission and further cements the success of this venture into space exploration. The data gathered from this meteor impact will be incredibly valuable to scientists as they continue to learn more about the Martian atmosphere and interior, providing further insight into our planet's structure and possible changes it could experience over time. With continued success, InSight could provide unprecedented information on how planets change over time and how impacts can create seismic events in other worlds. Ultimately, this type of research helps us better understand the universe around us. This powerful Marsquake could have big implications for future exploration of the Red Planet. By providing a better understanding of the internal structure and composition of Mars, scientists can create more accurate models for predicting seismic activity on the planet, which is essential for planning missions and designing habitats that can withstand potential ground shaking. Furthermore, this discovery could help us better understand how Mars evolved over time and what its past must have been like in terms of tectonic activity. This knowledge will be vital when it comes to searching for evidence of ancient life on Mars or looking for resources that could be used by future human explorers. Understanding the Martian core's current state is also important for any plans to terraform the world in preparation for human colonization. Overall, this powerful quake is an incredible discovery and could provide a wealth of new information about the Red Planet. So this brings up the question: could Martian seismic activity become a threat to human presence on Mars? While it is unlikely that Marsquakes of a magnitude observed by InSight could injure or kill astronauts, they would likely be felt and could disrupt operations. Regular monitoring of seismic activity on Mars would be necessary in order to prepare for any potential disasters, as well as to aid in understanding the structure and composition of Mars's interior. The data collected from InSight has already added greatly to our knowledge of the Red Planet, but greater understanding is still necessary before humans can safely explore the surface. Martian seismology will continue to provide this increased level of insight into Mars's subsurface features and processes. So far, the lander has made amazing discoveries, but the lander still has more time to investigate Mars. The lander's solar panels are losing power due to dust accumulation, which will eventually cause the spacecraft to shut down. It's challenging to predict with accuracy when the lander will shut down, but based on the most recent power assessments, engineers currently think it may happen between October of this year and January 2023.